Hi, my name is Graceanne Montou, and I'm a first grade teacher at Kinder Elementary in Allen Parish. I'm very passionate about two things, one inside the classroom, one outside the classroom. Inside the classroom, I am very passionate about teachers being intentional with the way that we teach our students. We need to be teaching our students to become good critical thinkers, problem solvers, good readers, mathematicians, and increasing that math and reading fluency in them, and stop teaching our children how to guess. We have all these research-based strategies that we need to be using in our classroom. Outside of the classroom, I am very passionate about obtaining and retaining teachers. We need to do a better job of advocating for our profession and encouraging young people to become teachers and telling them how great of a career this is to choose. I'm a big John Hattie fan, and one of the greatest effects that can be put in a classroom is collective teacher efficacy. So we need to get more teachers who want to be teachers and want to continue growing. We also need more teachers who want to become mentor teachers to help teachers along the way in their classroom and in their practice so that we can all grow. Today you are going to watch me teach a math lesson. Whenever I was growing up, I didn't feel like I was a math person. Little did I know that I was just learning math in a way that I don't want to teach my children. I'm very passionate about teaching things the way that they're supposed to be taught. So I utilize the Louisiana State Standard Rigor documents often to make sure that I'm teaching it the correct way. And this lesson that I'm teaching is both procedural and conceptual. And since it's the first time that I'm teaching this particular strategy, I'm going to be hitting heavy on that conceptual component so that they understand why I'm doing it the way that I'm doing it. This lesson is called Making a 10 whenever 5 is an add-in. And I love this lesson. I love this whole module because this is how I do math in my head, and I remember doing it whenever I was a kid this way. So I'm very passionate about teaching this to my kids. To prepare for this lesson, I completed something that our district implemented called a UBD, which is an understanding by design, and it really just helps us to unpack our module and the heavy-hitting standards and what's really like the meat of this module. I then prepared for this lesson by completing a module study, annotating my module, editing my slides, and reviewing past exit tickets and my end of module data. This lesson sets the students up for adding as they can compare efficiency with past strategies that they've learned, and they'll eventually see that making a 10 might seem tricky at first, but it is the more efficient strategy rather than counting on or counting all. Our school's focus right now is on math, and I'm really focusing on taking that conceptual piece and implementing my students. That way they can understand why we are learning the things that we're learning. I engage in productive struggle a lot. I want them to be able to work through their problems before I intervene, and that's something that you're going to see. I have a few struggling learners that I pull to the middle of the floor that I work with while we're doing our problem set, but before I do intervene, I let them go for about as long as they can. My overall goal for my students for this lesson and this topic in math is for them to become more efficient in solving their problems. We're about to start adding larger numbers together, and this making a 10 is like the first stepping stone to help them become more efficient in adding and subtracting numbers. Some adjustments that I've made to this lesson is I've edited my slides to the point to where I could show the students what doing this kind of strategy looks like concretely, abstractly, and in a pictorial method. That way they can kind of see where they're at and where we're going. Because I mean the goal is for them to do it in their head eventually, but before we get there they need to see what it looks like, you know, with cubes, with a picture, and then with a number bond. I want math to be something that's fun for my students, so after the exit ticket we play a game that you're going to see, and this is a great way for them to show what they know while also I collect data to see how I can further make adjustments. I have 19 students, and they are a brilliant, great, bright group of kids, and they make me so proud to be their teacher. I hope you enjoyed today's lesson. This is always something that's so fun for me to teach.
Alright guys, so for today's lesson, we are going to learn how to make a 10 whenever an add-in is 5. And remember that add-in is just another word for part. So before this lesson, we were adding equations that had 3 add-ins, and 2 of those add-ins would bundle together to make a 10. Now, why would we want to make a 10? What's the whole point of us wanting to make a 10, Nicholas?
Because we type it in and put the other number, it would be easy to make together.
Very good. So whenever you add any number to 10, it's easier to add, and you can do it quicker, and you can do it more correctly. Sometimes it's a lot harder to add numbers together whenever you're drawing a picture or whenever you're using cubes. So whenever we add a number to 10, it's normally a lot faster. So before we get into the thick of this lesson, we're going to warm our brains up. Are you ready?
Yes, ma'am.
All right, so since we are bundling 2 parts to make 10, and one of those parts is going to be 5, we're going to practice that by taking 5 out of a number. So watch as I do this first one. I have the number 6. Hold up 6 fingers. Now take out 5. What do you have left? Wait for me to snap.
1.
1. Very good. So I have 5 plus 1
equals 6.
Very good. So now we're going to try this with another number. You're going to take 5 out of that. I need a brave volunteer to come up here and tell me what's left after you take 5 out of 7. Ooh, looks like I got a lot of brave volunteers. Number 4. Very good, Mia. Can you explain to the class how you knew that? Look at the class.
Because
How did you know that it was 2 left?
5 and 2 make 7.
Very good, because 5 and 2 make 7. So she added 5 plus 2 to get 7. What's another way we could know? So our learning targets for the day. We are learning to use the Make 10 strategy when 5 is an add-in in order to add more efficiently. That's a lot of words. All right, so remember, a strategy is something that we use to help us solve a problem. The strategy we're learning about today is called the Make 10 strategy, and that's exactly what it sounds like. We're taking 2 numbers and putting them together to make
10.
Very good. We're doing that in order to add more efficiently. What does efficiently mean? What does efficiently mean, Tucker?
Quick but right.
Very good. Efficiently means quick but right. We want to do these math problems quick so we're not spending a lot of time on it, but we also want to be correct. So the Make 10 strategy allows us to be efficient, which is quick but right. All right, our success criteria says I can bundle 5 and some more to make a 10. So whenever I say 5 and some more, what does that mean, 5 and some more? How many more would 5 need to become a 10, Eli? Add another 5. Very good. I want you to read this first equation with me.
5 plus 6 equals blank.
Very good. So we have this rec and rec demonstrating what this 5 plus 6 looks like. Now we've learned in past strategies that we can either count all these beads, we can put some of these beads in our head and count on, but today we're going to do something a little bit different and we are going to make a 10 with these beads. So on my real rec and rec, I'm going to show you what this looks like. So we have 5 plus 6. What do you notice immediately about these beads that are shown on my rec and rec? What do you notice about them, Peyton? Oh, very good. So we see that there's 2 sets of red, and then we see 1 white one right here. What do we know about these red beads? What do we know about these red beads, Mia?
You have 5 and 5.
Very good. The red beads each represent 5. Now, what happens if I put 2 5s together? Tell your partner what would happen if I put these 2 5s together. Would it be easier to add 5 plus 6 or 10 plus 1, and why, Nora? And why would it be easier to add 10 plus 1? Why do you think it'd be easier to add? Help her out, Zai. Oh, you think it's easier to add another number to 10? I agree. In fact, whenever I was in 2nd grade, I wanted to tell my teacher so badly about a strategy of this big number 9, and whenever you added a number to him, he had a net and he would steal 1 more from the other part we were adding to, and it would make a 10, and then I would just add the leftover to it. And I'm so happy that I get to teach this to you today because this is my favorite strategy. In fact, this is how I do math in my. I'm going to demonstrate the cube model. So we have the equation 5 plus 8 up there. So we're going to put our cubes out in groups of 5, and I'm going to show you how to make a 10 whenever you have cubes. So help me put 5. 1, 2, 3, 4, 5. Very good. Now help me put 8 more cubes down. These cubes are in a different color. They represent the different parts that we're adding. Ready? 1, 2, 3, 4, 5. Move on to our problem set where we're going to use what we just learned and work together. So the first one I'm going to do, and you're going to watch me. Then number 2, we're going to do all together. And then 3 and 4, y'all are going to do by yourself before we move on to our exit ticket. Whenever we do 3 and 4 by ourselves, once we're done, we're going to stop, put our heads down to signal that we're ready to go. And then once we're all ready to go, our partner is going to give us feedback if there's anything that we can do differently. Are you ready?
Yes, ma'am.
All right, so to meet our learning target, we said that we're using the Make 10 strategy whenever we decompose a number to turn 5 into 10. So I'm turning this 5 right here into 10. So I have 5 cubes plus 9 more cubes at the bottom. How can I turn that 5 into 10? What can I scoop up, Nora?
5.
Okay, so I can take 5 from this 9 down here. So I'm going to circle these first 5 cubes. then the 5 up top. And now I have what? Once I bundle 5 and 5 together, I have, wait for me to snap,
10.
Very good. I have 10. So I'm going to put my 10 right here. What are we going to do with our equation? How are we going to write our equation? Aubrey?
We're gonna put the equation down here, and then turn it by the color we're gonna put it.
Okay, so one.
Type at the top and type at the bottom because it equals 10 and one more is out, so 10 plus 11 equals 11.
We are going to do a debrief of what we learned today. So we're going to revisit our target. What was our target for today, Griffin?
The 5 and 10.
Okay, very good. We are going to bundle 5 with 5 to make a 10. Now, why would we want to use the make 10 strategy? Why do we want to use that make 10 strategy, Nicholas?
Because if you make the 10, then you can go on easier.
Very good. If you make the 10 first, then it's easier to keep going. What's it called whenever you're quick but right? What's that called? Libby?
Efficient.
Efficient. Very good. So we're working to become efficient learners and efficient mathematicians. So we said that our don't forget to write your 10 plus equation. Don't forget to write your 10 plus equation underneath. What'd you do?
I started 6 into 5 and 1, then this 5, I put the 5 and then separated them. Then I put this 10 is it, then the last one, left is 1, so it's 10 plus 1 equals 11. I did 5, so I put 8 and then I put 5, and then 8 plus 2 equals 10, so I circled 10, and then I had 3 left, so I did 10 plus 3 equals 13, so this equals 13 too. Because your turn. Okay, I had 5 dots and then I circled the other dots, but I needed 5 more, so I circled that. Then I put my 10 equations, and then I put 3 in it because there's 3 in my left, not circled. Circled 10, and then they had 4 left, and then I did 10 plus 4 equals 14, and then they have 14 left. I circled 5 by here, 5 by here, and I have 4 more left. 10 plus 4 equals 14.
So in a lesson, I like to go very in-depth with my learning target and success criteria so my students know what the objective is and how to get there in a clear and concise way. Based off of our exit tickets and the game data that I got from this lesson, I can see that my students were successful in obtaining that objective. They were able to decompose an add-in and add it to the other add-in in order to make their 10 and then create that simpler equation. I used my exit tickets and the game data to verify this, and then if I had any hesitation, I used my checklist and I would ask a student a question and they would verbally reason why they did something the way that they did. The only problem that some of them had was the decomposition part. So I quickly intervened with them, and not in a serious intervention, just kind of like a touch up here and there, and showed them concretely how we decompose before we move on to the abstract version of that. From here, we are learning to make a 10 with 9 as an add-in and with 8 as an add-in. So today was a good roadmap to see how successful they would be with this strategy. And for today being the first day that they learned it, I'm very impressed with the way that they handled this strategy, and I'm anticipating great success whenever 9 is an add-in and whenever 8 is an add-in.